So in the last video, I began introducing the foundations of my attempts to construct an ecological notion for macroeconomy within the context of a cooperative economy more generally. And before introducing some of the primary categories that Ulanovich uses to describe these this notion of process ecology, I wanted to contextualize the notion and the framework itself more readily. And in order to do so, I will need to engage in some storytelling as to the origins of this revival in so-called Milesian thinking, as Ulanovich describes it as. And I think one can trace back the roots to this renaissance to the Macy Conferences that began in the winter of 1946 and went on until 1960. There were 9 of these in total. Many very influential and also famous scientists were part of them, and their intent was to create a foundation of interdisciplinary dialogue, and they saw in fact the genesis of many modern scientific disciplines, including complexity theory, systems theory, cybernetics, amongst others. And there, in fact, there of course were not only agreements but also disagreements within the context of these conferences, and thus what Ulanovich refers to as this Milesian school of thinking, I think in particular, although it had its roots again in these conferences, really has had its impetus in after the end of these conferences in the 1960s and 70s. Again, similarly to the Basaglia I mentioned in prior video, his roots in the anti-fascist struggle and in the new left movements of the late 1960s. Again, the movement towards what is called second-order cybernetics was, in my view, very influential towards the foundation of this renaissance in Milesian thinking. Now, what is second-order cybernetics? Ask any cybernetician and they will give you a different answer than the next. But I would reduce second-order cybernetics to, firstly, to describe cybernetics. It is in many ways, a theory of control of servo monitors. So a thermostat is a very good example of a cybernetic phenomenon, as the thermostat both measures and influences the temperature in a room. So it has both a thermometer that actually measures the current temperature, and when the user sets a certain boundary or threshold, this temperature is reached, the servo mechanism then activates the heating or cooling system, depending, and then continues to activate that until the desired temperature is reached. And then as the thermometer measures the desired temperature, the heating or cooling system is then cut off. So it is a study or a science of control that in fact studies the feedback of a control system on an observational system and vice versa. And second-order cybernetics takes this study a bit further and was in fact inspired greatly by the thinking of Margaret Mead in her journeys to Papua New Guinea and Fiji in the 1960s with her husband Gregory Bateson. And in fact, one can say it is it discusses the control of control and the communication of communication. So it, I would say, takes the level up. It goes up one level and looks, for instance, at the relationship between the users of these systems and the control to which they are privy. Having said that, I can now move on to discussing some of the more detailed concepts of process ecology, beginning with the aleatoric. The historical opposition of the Eleatic and Milesian worldviews, according to Ulanovich, can be seen in the two opposing categories of state versus process variables. While historically within scientific discourse, the former, that is, state variables, have had the dominant position, in part due to their ease of use. For instance, the fact that they are perfect differentials. The increase in interest in process variables has come about with the burgeoning interest in networks wherein flows are accorded parity with states. That is, the connections between nodes are seen as just as important as the nodes themselves. Thus, it becomes likely, as Olanovich argues, that the groundwork in thermodynamics may soon shift in favor of flow variables. Thus, while the two views, the Eleatic and Milesian, first appear to be irreconcilable, the stranglehold of essentialism on scientific thought, argues Olanovich, has been broken with the Darwinian descent with modification. So Darwin's revolutionary contributions have shown that there is some process involved in nature that's teleological, that is not teleological, actually, I should say. However, argues Ivanovic, although change became possible with the Darwinian notions of descent with modification, its radius, the radius of change, was circumscribed. Darwinian change acts only within type, species, and the process is not open to the generation of new types, that is, speciation. The observation that Ulanovich made is relevant not only for biology, but has implications for all behavioral or social and complex sciences. Particularly, it points to one of the foundational antagonisms between chance, and the goals of science. Whereas science aims to codify, simplify, and predict, the interjection of chance into the narrative results in conspicuous exceptions to regularity, complications in specifying the system, and degradation of the ability to predict. This antagonism manifests itself in the near universal application of probability theory to scientific discovery, raising an issue that I have brought up briefly in the prior module, module 2. No, actually, it's at the beginning of this module. I think it's in the second video of this module. Ulanovich observes that applying probability theory forces one to accept a set of assumptions regarding how chance is distributed. That is it normal, exponential, or by a power law, and so on. Moreover, probability theory can be used only after a more fundamental set of assumptions has been accepted. These essential preconditions are only rarely mentioned in introductions to probability. Namely, probability applies only to chance events that are simple, generic, and repeatable. Simple means that the events are atomic in nature and occur at the smallest scale of observation. Generic refers to the observed phenomena being homogeneous in quality. And repeatable means that the phenomena must be observable in infinitely repeatable situations. In this vein, the physicist Walter Elsasser's pioneering work concludes, argues Ulanovich, that complex chance events prevail everywhere there are living systems. More surprising still, Elsasser implied that they perfuse nature and even overwhelm the number of simple events by comparison. This becomes especially clear in Elsasser's attempts to use combinatorics to study the number of possible events comprising the universe. Elsasser concluded, argues Ulanovich, that at the very most 81 times 100 or 1025 or 10 to the 26, 10 to the 106 simple events could have transpired. One can safely conclude that anything with less than a 1 in 10 to the 106, that is 10 times 10, 106 times, chances of reoccurring simply is never going to do so. even over many repetitions of the lifetime of our universe. Thus, according to Ulanovitz, Elsasser's conclusion relates to complex systems like the cooperative economy by way of uniqueness. In particular, he writes, one asks how many different types or characteristics are required before a random combination can indisputably be considered unique. That number is surprisingly low. Only around 75 unique components render a particular system unique. It is easy to demonstrate that this observation applies to virtually all social systems, including the cooperative economy. Here, as elsewhere in the social realm, singular events are not rare, rather, they are legion, according to Ulanovitz. He argues furthermore that Elsasser robbed us of our innocence and underlines the ontic nature of chance, i.e., that chance is not merely an illusion to be explained away by the operation of laws. This implies that the world is not a seamless continuum, that in fact the fabric of causality is porous. Therefore, the universe is not causally closed, but open in the sense of Karl Popper and Charles Sanders Peirce. So the question must be raised if the standard frequentist approach to probability is of no use in measuring aspects of relational or cooperative governance or assessing the effectiveness of this versus uh, that policy with respect to discourse ethic, then how do we proceed? Just to recap, the notion of the aleatoric involves the chance or random events, the notion of indeterminacy in the universe, and especially in complex systems, and thus it describes the chaotic nature, in fact, of much of the history of the universe. But it does so in a way that is complex and interdependent. Thus, this notion of porousness is probably the best metaphor or image that we can use for describing the notion of the aleatoric. Next, I would like to introduce the notion of propensities. And in fact, Ulanovitz argues that this porousness of the fabric of the universe does not imply that the laws of causality are violated. So, while the aleatoric again shows us how things change, the question, of course, is how they then persist. Instead, the proposal at hand is simply that physical laws are incapable of determining what we see in the living realm, that the combinatorics of complexity simply create so many possibilities or degrees of freedom that any physical laws can be satisfied in a vast multiplicity of ways. Another way of saying the same thing is that the realm of biology is undetermined by physical constraints. In other words, nature and living systems are rife with heterogeneity, which may remain hidden. The conclusion one must arrive at is, according to Ulanovitz, one cannot formulate a law in the Newtonian sense that would relate to the operation or operations among heterogeneous biological classes. This fundamental heterogeneity overwhelms law in the sense that a law cannot differentiate between the multiple historical paths a system actually took to arrive at a particular state. This indeterminacy renders much of the mechanistic language of modern social science, read economics, metaphorical at best. Citing Karl Popper, who felt it was wrong to stretch the narrow notion of force to pertain to complex situations where, again, it could possibly lead one astray from what was actually happening, Ulanovitz suggests that one should adopt instead the language of propensities. If A happens, there is a propensity for B to occur, but B need not follow each and every time. The situation then becomes more like if A, then B, if A, then B, if A, then B, if A, then C, if A, then B, etc. That is, As opposed to mechanistic causes leading to deterministic outcomes, propensities represent constraints, albeit imperfect ones, capable of holding systems together. So Ulanovich. The concept of propensity introduces ambiguity and indeterminacy into the analysis, important qualities within the complex domain of social sciences. That is, propensities impart adequate coherence to a system to keep it from immediately disintegrating when impacted by the most arbitrary singular events. And relevant to the current topic, propensities never exist alone, but always stand in relationship to other propensities. And one can speak in this regard of ensembles of propensities. I return to this topic again when discussing the last two cooperative principles. Next, the notion of autocatalysis, which relates to these propensities. And in fact, the propensity and the aleatoric appear then to be two sides of processes that regulate change in complex systems. Again, I asked the question following Milanovic, how do things change on the one hand, and on the other hand, how do things persist? And again, this notion of the aleatoric and also of propensities seem to be parts, at least, of the solution to this question. Two other phenomena, in addition to propensities and the aleatoric, that facilitate these elements are causal circuits and feedback. And again, back to the beginning of this video, I mentioned the notion of the cybernetics and these Macy lectures as the genesis of this renaissance in the Milesian way of thinking. And again, causal circuits are an integral part of the original notion of cybernetics. And again, think of the thermostat that you have in your home, where there in fact is a causal circuit. If the temperature gets below or above the desired bandwidth, then again, this servo monitor again activates the heating or cooling system. And again, this is both a causal circuit and an effective feedback upon the system itself. The two concepts, in fact, of circuits, causal circuits and feedback are related, with causal circuits entailing concatenations, that's a long word, of events or processes wherein the last element in the chain affects the first. Again, in this case, it could be the observation that the temperature is too low, and again, that affects the temperature. What is commonly known as feedback. Gregory Bateson has argued that, in principle, a causal circuit will generate a non-random response to a random event. So if someone opens a window, the temperature lowers, and the servo monitor commands the heating system to activate again. This is a non-random response to a random event. Therefore, causal circuits have the capability to endure because they can react non-randomly to random stimuli. So Ulanovich. The question then becomes how to introduce feedback effect into scientific analysis without resorting to circular logic. Now, Ulanovich suggests that by gathering all feedback into a single postulate, one excises circularity with one fell swoop from all subsequent arguments. Now, he has written extensively on this topic, and I'm, of course, in communication with Bob, and he's actually recommended a paper to me where he developed, in fact, an algorithm where all of the feedback systems within an ecosystem can be separated out into one logic, and that leaves only the non-linear directed graphs that remain, that show the relations amongst the system's components afterwards. And in fact, combining such an approach into what is called second-order feedback, we get autocatalysis. And this is, in fact, what the algorithm actually entails. Autocatalysis is a particular form of positive feedback wherein the effect of every consecutive link in the feedback loop is positive. Such facilitation need not be assumed obligate and rigid, as with a mechanical system. There simply needs to be present the propensity for each participant to facilitate its downstream member. So Ulanovich. Autocatalysis displays a number of properties, including being growth enhancing, providing a formal structure in which processes and events may configure, being capable of exerting selection pressure upon its own ever-changing constituents. That is to say, the selection pressure arises from within the system, different than this notion of a servo mechanism. The interesting thing about autocatalysis is that it is a scalable value. It can be used to explain both organizational networks, and it can be used to explain notions like consciousness, which can be seen as a autocatalytic vortex that is centered on what we call mind. Of course, in this case, we have things like the pituitary system, the neurological system, and other immunoresponses, et cetera, that define what a human person is. And in fact, this is what Gregory Bateson was discussing when he used the term an ecology of mind. Of course, this system is not necessarily constrained consciousness to the mind or even the body, but extends even beyond in some cases, such as the example that Gregory Bateson makes of a blind man walking through city streets. Where does the system that consists of the blind man start and where does it stop? He asks the question, does it stop at the tip of the stick that the man is using to estimate any obstacles in his way, or at the beginning, at the end of his hand? And in fact, Bateson concludes that this system entails both the man, the stick, him walking, the street and the environment, and the stick again, and the man, and again, going back and forth. So all of these things are involved and can be used to explain such processes very usefully. So it follows from this notion, now that we've discussed the aleatoric propensities and autocatalysis, so we can sort of get to the developments that arise from the interaction of these various processes. So asking questions such as how things can change leads one, as I said, to acknowledge the aleatoric. If an event is unique for all time, it evades treatment by probability theory. Now, if the density of unique events overwhelms that of simple ones, as it does in complex systems, then most of reality, in fact, lies beyond the lens of probability theory, Milanovic argues. In such cases, we must speak of radical contingency, which leads to the first proposition, and that is that the operation of any event is vulnerable to disruption by chance events. So just to attach an image to that idea, cooperation can in fact be seen as such a chance event, as Axelrod has actually shown. In his case, when there were two bacteria that are sharing certain elements for reproducing, and say there's an event where one bacterium is taking more than its share, then that cooperation can in fact be interrupted. Note that we speak actually of systems as ensembles of processes possessing varying degrees of uniqueness. Talking about laws and mechanisms in such instances appears misleading at best. Thus, we cannot speak of a law of cooperation, only of particular tendencies, logics that comprise both formal and informal, institutional, organizational, and individual attributes and relations among these attributes. Abandoning the Eleatic thought style for the Milesian is called for in such situations. The second question scientists ask is how things persist. Again, this is what I mentioned earlier. How does order arise and appear out of the aleatoric, for instance, in the form of a regime of cooperation? The notion of propensities that we have actually discussed immediately previously, and the concurrent ideas of causal circuits and feedback appear to sufficiently answer this question. Accordingly, asymmetric shifts in system dynamics cause persistent changes in the structures of those systems, maintaining the Milesian focus on process and, as Milanovic argues, recognizing that stationary forms are subsequent to movements and processes. The question could be rephrased as the following: what process or combination of processes might yield ordered form out of chaotic substrate. Therefore, the fact that autocatalytic processes react non-randomly to chance events, as I mentioned previously, provides the answer to why things persist and gives us the second of these three uh, propositions, which is a process via mediation by other processes may be capable of influencing itself. Thus, the action of autocatalytic feedback tends to import the environment into the system or alternatively embeds the system into the environment. In the case of cooperation, the chance events that lead or led to its emergence as an ascendant macroculture can then be formalized to engender cooperative processes as normalized reactions to a multiplicity of events. Doing so requires the importation of the environment as seen in the importation, albeit in a circumscribed form, of earnings cost logic into the second and fourth cooperative principles. That is, the second and fourth principles import the general economic environment, the rules of market logic and competition, into a general framework of cooperation, and thus allow individual cooperatives to then exist within this set of constraints and respond non-randomly to these rather uncoordinated events. At this point, we have a basic cybernetic framework to describe system dynamics and can interpret these dynamics for the cooperative economy. But one element is still missing. As I mentioned, there are three propositions. So the autocatalytic process of that cause persistence of systems does not yet describe how the unique identity of various systems comes about. How does, for instance, a beehive differ from a coral reef? And how does a consumer cooperative in post-war South Korea differ from one in contemporary Switzerland? They differ in their respective histories, which have been influenced by particularities partial to the locality in question. These histories are encoded as information within the various laws, statutes, and norms that regulate the various respective organizations. Therefore, the third postulate is that systems differ from one another according to their history, some of which is recorded in their material configurations. Therefore, relating the third postulate back to the main subject that we've been discussing in these videos, in many ways, the structure of activities within a society embodies the history of that society every bit as much or more than the aggregate DNA of the individuals that make up the community. The role of information in this process, of course, is central, and I will return to that in a moment. And these three propensities, or excuse me, a lot of propensities here, these three propositions actually themselves then entail three associated shifts. The first of these is that in order to understand living systems, emphasis should shift away from fixed laws and toward the description of process. This first shift means that the focus should be placed on what Popper calls propensities, which he described as not mere possibilities but physical realities, instead of fixed laws. The second shift is that relevant agencies in living systems reside more with configurations of propensities than with explicit physical forces or their attendant objects. This second shift merely underlines the shift from object-based to process-based thinking. This shift, which occasions a major reorientation of our thinking, means that configurations of processes or propensities, rather than objects, become the focus of our attention in explaining how and why things happen in studying complex systems like the economy. Lastly, there is a shift from equilibrium to second-order cybernetics thought styles. These emphasize the influence of opposing tendencies and should therefore play a central role in economic analysis generally, but particularly are important in analyzing the cooperative economy. And again, these opposing tendencies can be the observation of a decrease in temperature with the concurrent increase in temperature that is then produced by the servo mechanism that starts the heater. So again, these are two opposing tendencies. And again, these tendencies in this case can be order and chaos or what have you. The point is that cybernetics is based on the thinking of basically the analysis of the interactions between opposing tendencies. You can just call them tension. The shift entails acknowledging that patterns and forms in the living realm must rather result from transactions between agonistic tendencies. And everyone should know now what agonic is. I've talked about it enough in these videos. Processes that build organized activities are continually being eroded by dissipative losses. While these tendencies oppose one another in the near field, they are seen to be mutually obligatory under a wider vision. And this is very important. This shift, in fact, can be summarized with the heuristic never push single goals too far, because doing so invariably leads to system catastrophe. So again, the agonistic tendencies can be things like cooperation versus competition, and one can see at one level they are in opposition, but at a higher level they are ultimately mutually obligatory. Again, as Ulanovich says, under a wider vision. So without cooperation, no competition, and without competition, agonic pressures, no cooperation. This third corollary shift cannot be strongly enough emphasized and underlines the shift in thinking since roughly the advent of the Club of Rome in 1972. Taken together, these three propositions and the three corollary shifts reorient analysis of complex social systems like organizational networks based on relational contracting in a way enmeshed in second-order cybernetics. This means we are aware of and embed feedback effects between system and components into the analysis instead of considering such aspects post hoc as within the domain of ontological individualism. As such, a useful next concept to discuss is ascendancy. Ascendancy is seen by Ulanovich not as a challenge, but a fruition of the Darwinian paradigm. Fitness, as he asks, as used by Darwin, has always prompted the question, fit for what? Community ascendancy imparts an appropriate direction to the fitness of a population without necessarily implying a fixed goal in the teleological sense. Thus, the basis of ascendancy, one of Ulanovich's more central categories, and a central category to process ecology, is dual. The first element, average mutual information, or AMI, is a reflection of the fact that a system must attain a certain level of complexity before it can interact with its environment in a way that increases its own organization. Precisely speaking, AMI is a logarithmic index from the mathematical field of information theory as a functional measure of organization. So this is basically represents the size of a system. And to this size-oriented quality comes the second element, conditional entropy, or CE, which is equivalent to the notion of redundancy that I would introduce in my dissertation in the cooperative economy towards a stakeholder-led democracy. Conditional entropy gauges the system-wide of parallel connections. Ulanovich emphasizes that increasing ascendancy is not the only tendency at work in the dynamics of developing or evolving systems. Indeed, conditional entropy speaks to a central role for disorganized elements in the resilience of systems. Indeed, part of resilience entails the ability or freedom of a network to adapt to novel or unforeseen perturbations. And so we can observe that systems tend towards stability, they don't reach it. Both ascendancy and overhead draw from the same limited resources. So at some limit, one cannot increase the one, for instance, order at the expense of the other, that is, possible alternative configurations. So this means that a system, of course, can be decomposed into several characteristics, one of which is the structure of the system, and the other the size of the system. So to the extent that elements are connected to one another, at a certain point of development in the system, these particular connections actually detract from the ability to alternatively reconfigure that system. So again, you cannot have your cake and eat it too, would be one way to interpret this. Having a system that is too ordered, it can make it brittle and prone and vulnerable to collapse. And on the other hand, having one that has too many potential but not realized connections can make it degenerate and and yes, not really survive. So Ulanovich speaks of a window of viability where there, in fact, is an agonistic and balanced relationship between order and chaos, or using Nietzsche's terminology, we can speak of the Apollonian and the Dionysian. This limit, of course, the point at which the agonic forces impact the other, owes in part to how finely the available resources and their sources can be divided. Therefore, at some point in the growth and development of a system, the complementary forces of order, ascendancy, and disorder, which Olanovich describes with the term overhead, which means this is sort of the rest, this is the chaotic element, this is the unorganized, disorganized element within the system that allows for potential reconnections and adaptations and also transformation into new forms. And this relationship at some point becomes antagonistic. After this point is reached, either may continue to grow at the expense and only at the expense of the other. This observation, in fact, reveals a very real opposition in the world of complex systems, like the economy. Thus, real systems are the result of an ongoing transaction between the opposing tendencies of both ascendancy and overhead to increase. The Apollonian and the Dionysian exist in a tentative symbiosis as long as a system's complexity is increasing, else one increases at the expense of the other. Thus, a transactional universe and a relational economy exhibit characteristics like increasing order and a dialectical antagonism between order and a degree of redundancy. However, this antagonism is itself part of the ordering process and can first be recognized at a higher level of organization. Again, going back to Bateson's notion of a double bind. This is the Goldilocks phenomenon that we've already referred to continually throughout these lectures, states Ulanovich that the larger picture of dialectical and dialectics goes beyond simple antagonism as an observation attributed largely to Hegel, who I've discussed in Module 2. Hegel noted how opposing tendencies can become mutually dependent at some other level by consideration. Such dependency at higher levels circumscribes the antagonism between ascendancy and overhead. So something that is in opposition can actually be in symbiosis when looked at in a certain different perspective. So if we look at the system level, these two opposing tendencies may in fact reinforce one another. And this is the point. And so in practice, the point should be that, of course, an economy cannot always focus on growth, maximizing missions or goals, and at some point has to look into the ordering activity. And of course, this is a great boon for the cooperative economy and an argument for increasing the number of cooperatives in existence, because it suggests that focus should not be put on the efficiency of the organization, its cost effectiveness with respect to others, but in fact, its effectiveness at increasing the connections between its various stakeholders and between them and their community, and vice versa. The last category that I would like to introduce from process ecology, and maybe some of the listeners and viewers have realized that this is a very useful set of concepts and have actually stopped the video and are now off ordering books by Robert Ulanovich. So I won't interrupt you from that. But for those who are still here, as mentioned, many economists pursue the goal of market efficiency to its monist extreme. In the process, they ignore that which imparts reliability to a community, as I said, such as functional diversity and equity of wealth. With their zeal, they unintentionally set up a society for a fall. And if one takes away only one idea from this thesis, argues Dolanovich, or he states or appeals, it should be that pursuing a single variational goal while failing to consider its agonistic counterparts leads invariably to a bad end. Directions are essential elements of the evolutionary drama, but like the propensities that give rise to them, they never occur in isolation. So, this notion of irreversibility is very important. I recently read in a paper by Steve Keen that the notion of climate policy is being conducted in many ways like an irreversible social experiment on the only planet we have to our disposal. So, also appropriating this notion of irreversibility. Vodanovich's notion that I just quoted or cited calls for a metaphysical patience, or a willingness to admit that we inhabit, as Ilya Prigonia and Stengers put it, a world of radical uncertainty. Such a worldview would attempt to organize human social activity in such a way as to reduce human encroachment upon natural ecosystems to an accommodating minimum. It thereby relates to Popper's notion of intellectual tolerance that I have spoken of previously. Each of these perspectives appears to support a search on the part of scientists and the broader human community as to how to organize the remaining incursions on the natural biosphere in a democratic manner. Because constraints promote scarcity, which in turn raises the specter of competition for scarce resources, human intelligence needs to create systems for fairly allocating such resources via an active multi-stakeholder dialogue, thereby enabling the mutualism that underlies natural, including human systems, to operate synergistically. Notions of stewardship that I've discussed, in fact, can facilitate this process. So in the next video, I will move on to discussing and modeling the last two remaining principles of the International Cooperative Alliance, that is Principle 6 and 7, cooperation amongst cooperatives and concern for community. So look out for that.